Right, welcome to lesson 11-5 on graphing nonlinear functions. So nonlinear function, first let's review what a linear function is. A linear function, you have your x and y axis, and you have, say, a point that goes through 0, 0, a point that goes through 3, 3, and then a line that connects them. This is the line y equals 3x. That's a linear function. It's a straight line. So a nonlinear function, it's not going to be straight. For example, if you had a line that curves like this, or a line that curves down like this, right? Anything that curves is nonlinear. So I'm going to go ahead and we are going to practice graphing nonlinear functions. So first of all, quadratic functions. Quadratic functions. You have the input value is always going to be squared. So for example, y equals x squared is quadratic because what I'm putting in is squared. Remember, you have an x and y table. Whenever you're graphing, you can make an x and y table. You have your input and then your output. It's a function machine, remember? What you put in, you do something to it, and you get another value out. So when we put in, say, 1 for x, y equals x squared, 1 squared, I'm going to get y equals 1. If I put in 2 for x, y equals 2 squared, y is going to be 4. If I put in 3 for x, 3 squared is a 9. This is a quadratic function. In general, it can be written as y equals nx squared, where n is a non-zero constant. The graph is always going to be, so your input's always going to be squared. Your graph is going to be called a parabola. Now, parabola means that it's a curved line, or it's a curve. And it can either open upward or downward. So, for example, we have our, definitely going to need graph paper for this lesson. We have our x and y axis. Let's say 1, 2, 3, -1, -2, -3. We're going to go ahead and we're going to graph the equation y equals 2x squared. Right off the bat, you know that this is going to be a quadratic function because your x is squared. Your input value is squared. You also know that because it's a quadratic function, it's going to be a curve. It's not going to be a straight line graph. So let's go ahead and make an XY chart, make a table. I'm going to do this for in order to graph these. Make a table. So we have x, and then we have our input y, which in this case is going to be 2x squared is our input. So if I put in -2 for x, we plug that into 2x squared for y. So 2 times negative 2 squared. Negative 2 squared is 4. So that equals 4 times 2 is 8. So my first point on my graph is going to be negative 2, 8. Oops. I need to add some more numbers to my graph here. I'm actually going to go ahead and I'm going to count by, actually I'll leave that. So this one's off my graph. I'm going to go ahead and do negative 1. Negative 1 is going to be 2 times negative 1 squared. So that equals negative 1 squared is 1 equals 2. So negative 1, 2 is the point I can put on my graph. Okay, I'm going to go ahead, keep going with my table over here. I'm going to put in 0. My y value is going to be 0. It goes through the origin. Let's put in 1. 2 times 1 squared. What do you know? That equals 2. Oops. Sorry, that's 1, 2. I'm going to put in 2. Now 2 times 2 squared equals, 2 squared is 4 times 2 is 8. So, it rather, I'm going to connect my dots here. It creates this curved shape going up, and it's mirrored on both sides. If I were to draw a dashed line, like my my y-axis is like the middle, it's the folding point essentially in your paper here, and it's mirrored on both sides. So for a quadratic formula, or for a quadratic function, a parabola, it should be mirrored on both sides of your axis. And it's that curved shape, so you're not going to connect the dots with a straight line, but you're going to just kind of sketch out a curve from the points. I'm going to have you go ahead and do an example with this. Go ahead and practice graphing a quadratic function. So you're going to need to make a table. Of x from, I'll start you on it, x, y, from negative 2 all the way up to 2. I want you to do the equation y equals negative 2x squared, and graph that. Pause the video once you have graphed it on your coordinate grid. You can press play and check to see how yours matches up. Alright, you should have written out negative 2x squared as your y. Like that's what you're going to be plugging in. You need to be showing your work for that. So negative 2 for x. So we'll plug in negative 2 times negative 2 squared equals, negative 2 squared is 4 times negative 2 is negative 8. Negative 2 times negative 1 squared equals, negative 1 squared is 1 times negative 2 is negative 2. Negative 2 times 0 squared equals 0. Negative 2 times 1 squared equals negative 2. Negative 2 times 2 squared equals 8. So let's go ahead and plot those points. So we have 0, 0. We have negative 1, negative 2. We have 1, negative 2. We have negative 2, negative 8. We have 2, negative 8. You sketch and draw a curve through there. And what do you know if you flip back to this graph, our first example, 2x squared, and our second one, negative 2x squared, it's the same curve, and it increases at the same rate. 1 is just flipped upside down because it's a negative. But again, so quadratic function, they're always going to be a curve. It's called a parabola. So again, not using your straight edge, but just sketching. And plot at least 5 points. Using 0. 0 tends to be where the parabola starts. Alright, let's move on and we're going to graph now a cubic function. So cubic function your input value is always cubed, hence cubic. It's raised to the 3rd power. So your equation here is always going to be y equals nx cubed, where n is a non-zero constant. So for example, example 2, if we have the equation y equals x cubed, we can, we'll go ahead and make a table. So we'll have our x and our y column, where y is going to be x cubed. So let's start with -2, -1, 0, 1, and 2 as our input values, and let's solve for y for each of those. So -2 cubed equals -8. -1 cubed equals -1. 0 cubed equals 0. 1 cubed equals 1. 2 cubed equals 8. So you'll notice here the signs change. It's not going to be like with our quadratic functions, the signs were the same for negative and positive numbers because it was squared. But cubed functions are not going to have the same signs. So we're going to go ahead and draw this graph out. Oops. 2, 4, 6, 8. Actually, I'm going to increase by 1s on my x-axis. -4, -6, -8. Okay, so -2, I had -8, plot that point. -1 was -1, 0, 0, 1, 1, whoops, 1, 1, and then 2, 8. So now for this curve, you'll notice it does not form a parabola, it doesn't form that U shape, but it is still a curve. It's not a straight line function. It's nonlinear. So whenever you have a cubed line, you're not going to have a parabola, but you are going to have a curve. I'm going to have you do practice with this. Example 2a. Go ahead and graph, do a table and showing all your work. Graph the function y equals 3x cubed. Pause the video, hit play when you're ready to check. Alright, you should have set up an xy chart where y is 3x cubed. So 3 times -2 cubed equals -2 cubed is -8 times 3 is -24. 3 times -1 cubed is -1 times 3 is equals a -3. 3 times 0 cubed equals 0. 3 times 1 cubed equals 3. 3 times 2 cubed equals 24. So I'm going to actually adjust my y values here. so you can see it on the graph. So I need to get up to 24. So I'm going to count by, no, let's see, I'm just actually going to switch to smaller graph paper to solve my problems. 1, 2, 3. I'll count by double squares on my x-axis. So 1, 2, 3. Alright, so I have 0, 0 as a point. I have -1, -3. I have 1, 3. I have -2, -24. Oops. And then I have 2 and 24. So I'm going to kind of connect those dots. And I have my cubic function. So we can, we'll practice with using graphs to solve a problem. So if you have a manufacturer, who uses the function y equals 1/4 x cubed to represent the profit y, you have your profit y, and in dollars, how much money is he making, right? From selling a single product, X, for selling a single product for X dollars. So the maximum possible profit, maximum possible profit is $3. So we want to estimate the amount the manufacturer should charge to make the maximum profit. We want to know what's the max charge to make the maximum profit. So how close can we get to $3 is what we're wondering. So let's go ahead and we'll start by graphing our function, and we'll see what's the number closest to 3 that we could charge for each product. So we want to know how much to charge. So we have the function y equals 1/4 x cubed. I'm going to make an x and y chart. So if x is, we can't have a negative, no negative charge, right? We can't have a negative amount people pay for x, for our object. So we're not going to do any negative values of x. So we'll start with 0, do 1, 2, and 3. So for 0, so y is 1/4 x cubed. So 0 times 1/4, or 1/4 times 0 cubed, 0. 1/4 times 1 cubed equals 1/4. 1/4 times 2 cubed, 2 cubed is 8, times 1/4 equals 4. 1/4 times 3 cubed equals 6 3/4. I'm going to go ahead and graph this. x and y axis. 1, 2, 3. 1, 2, 3, 4, 5, and 6. So 0, 0. And we have 1, 1/4. We have 2, 4. And then we have 3, 6, and 3/4. So I'm going to connect my dots there. Alright, so now the question is, looking at this graph, when y is 3, x is more than 2, but less than 3, but less than 2.5. Because we're wanting to know max profit is 3, right? And our profit y. So I guess I could label my graph that. This side is profit. So you want to know what's the maximum. So what's the value of, what's the x value when, so the charge of the product. When our profit is 3. So profit 3, we look across here, we say it's somewhere, it's after 2, because at 2 we're at, at 2 we're at 4. So it's in between, it's in between 2 and 3. So it's about 2.25. Is our approximate charge of what we should be charging for the product. Alright, so your in-class practice today. It's on page 594 in your textbook. I'm going to have you do numbers. Number 6, 14, 23, and 24. So you can practice graphing quadratic and cubic functions both a couple times. Number 24, or number 23 does ask you to look at the maximum of on a graph. So just like with our last example, looking for maximum and intersection. That's what you're going to be doing for number 23. And then your homework is the practice book page for 11-5 in your workbook. Okay, go ahead and get started.